What's up, everybody? This is Danny Mathematics here with another example to explore. Today, guys, I want to go over example 3 of how to solve inequalities that have variables or unknown values on both sides, okay? And a variable is an unknown value. It's a value that we need to solve for, right? So, in this particular case, guys, we have 6x plus 1 plus 6x minus 5 is less than, right? And if you watch my last video, guys, you know that inequalities signs, think about Pac-Man, okay? Think about Pac-Man. Let me draw the inequality signs right here. Think about Pac-Man, right? Pac-Man is always going to go towards the side that has more food, right? So if Pac-Man is facing this way, this side is the greater side. And this side is the least than side or less than side. If Pac-Man is facing this way, this side is the greater side, and this side is the less than or least side, okay? So once again, think about inequalities, think about Pac-Man's mouth, right? Pac-Man is always going to go towards the greater side or the side that has more food or more value, okay? So what we're trying to do is, guys, we're trying to find out what are the range of values x could be in order to make this whole inequality true, okay? So the first thing that, guys, that we need to do is combine like terms. I don't have any values that are in parentheses, so I don't have to distribute. All I need to do is just combine like terms, okay? So let's go ahead and do that. I'm gonna draw a line going through the inequality sign. It's always good to do that so you can split both sides, okay? And I'm gonna combine like terms. I'm gonna combine positive 6x with this positive 6x. 6x plus 6x is 12x. All right, and then I'm going to combine these numbers, 1 and negative 5 or minus 5. 1 minus 5 is negative 4. It's negative 4. It's less than, right? And then I have this opposite side, okay? I have no values to combine with 8x, but I can combine positive 2 and positive 6. 2 plus 6 is 8, okay? So I'm going to have 8x plus 8. Just like that, guys. So now we have successfully completed step 1, which was combining like terms. Now step 2, guys, we're gonna label each value, and then after that we're gonna label both sides. Remember, guys, wherever you see a heart, I'm talking about the coefficient that's in operation with a variable. And whenever you see an S, I'm just talking about the numbers that are not attached to a variable or X, okay? So I'm gonna put a heart underneath this coefficient of 12 and X because it's actually saying 12 times X, which is an operation or a relationship between both values, right? Okay, negative 4 is not attached to an X, so I'm gonna put an S for single. Okay, let me get a better marker because this one is going out. All right, on the opposite side, I have 8 and x. It's actually saying 8 times x, so they're in an operation or in a relationship with one another. All right, and then 8 is just by itself, so I'm going to put an s. Okay, remember in my last videos, guys, it doesn't matter what side you label as the relationship side and the single side, right? But I always choose the side that has the highest coefficient that's attached to x, the relationship side, just so I won't have to deal with negative numbers as I go through the process. But once again, it doesn't matter which side, it's the same process, okay? So now, guys, we're gonna move on to step 3. We're gonna move values on their correct sides by matching the symbols. All we gotta do is just match the symbols. If the symbols match, the value stays. If the symbol does not match, the value needs to move to the opposite side, okay? So 12 and x, they're in a relationship with one another and they're on the relationship side, so they stay. But negative 4 is single. It's not in a relationship or in an operation with x. So it needs to move to the single side, right? So the opposite or the inverse of minus 4 or negative 4 is plus 4 or positive 4. So I'm going to add positive 4 on both sides. I'm going to add it to 8 because that's a like term. And of course, negative 4 and a positive 4 cancels out on this side, okay? Once again, 12 and x stays. But on the opposite side, 8 and x are in a relationship, but they're on the single side. So they need to move to the relationship side. All right, the opposite of saying positive 8x is negative 8x. Negative 8x. Okay? So a positive 8x and a negative 8x cancels out. Okay? So now, on the left side, all we have is 4x minus 8x, which is, 12x. I keep saying the answer. 12x minus 8x, which is 4x. I was thinking about the answer. 12x minus 8x is 4x. And over here, guys, we have 8 plus 4, which is 12. All right, and in order for us to find out the value of x, we're going to finish it out with step 4 by dividing or breaking up the coefficient away from x, right? So I'm going to divide both sides by this coefficient of 4. All right, so 4x divided by x is this x. And then 12 divided by 4 is 3. So x can be any value that's less than 3. In order to make this whole thing true, x can be any value that's less than 3. So x can potentially be 2, 1, 0, -1, -2, -3, and so on, right? Any value that's less than 3, x can be, or x should be, in order to prove that this inequality is true, that this side is less than that side. So what I'm gonna do is, guys, I'm just gonna pick a value just to show you, okay? And I'm gonna pick the easiest value that you can pick, which is 0, okay? Because 0 is less than 3. So wherever we see an x, guys, I'm gonna plug in 0 just to show you that that value will make this whole inequality true, okay? So let's go on and do that. I'm gonna put check. And then also, ladies and gentlemen, in this particular example, I'm gonna pick a value that's gonna cause this inequality not to be true. So I'm gonna pick a value that's greater than 3 just to show you that that's gonna cause this not to be true, okay? The values have to be less than 3. So let's go ahead and check. So I have 6, and wherever I see an x, I'm gonna put a 0. I have 6 times 0 plus 1 plus 6 times 0 minus 5, right? And it has to be less than the other side, right? So let's just check. So I have 6 times 0, which is nothing. 6 times 0 there, which is nothing. And I have 1 minus 5, which is -4. Okay, and then I'm going to do the opposite side. And once again, -4 has to be less than this opposite side. So let's do the opposite side. I have 8 times x, which is 0. 8 times 0 plus 2 plus 6. 8 times 0 is nothing. And 2 plus 6 is a positive 8. So yes, guys, a -4 is less than a positive 8, right? So that proves that any of these particular values and any of these particular values will show that this side is less than that side, right? So the value has to be less than 3 in order for that to be true. So this is true, right? But then also, guys, let's do it the other way. Let's do a value that's not less than 3, okay? And a value that's not less than 3 is 4 or 5 or 6 or whatever you want to use. I'm going to use 4, okay? So I'm going to do the same thing just to show you that it would not be true, okay? So I have 6 times x, which is 4. I'm picking 4 as a value that's greater than 3. So 4 plus 1 plus 6 times 4 minus 5, right? Order operations, we multiply first before we add or subtract. All right, 6 times 4 is 24. 6 times 4 is 24. So I have 24 plus 1 plus 24 minus 5. All right, 24 plus 1 is 25. 25 plus 24 is 49. And then 49 minus 5 is 44. Okay? And remember, guys, we're trying to see if it's going to be less than the other side, which I know it's not, right? So let's go ahead and do the other side. I have 8 times 4 plus 2 plus 6, okay? So 8 times 4 is 32, and I have 32 plus 2 plus 6. That's 32 plus 2 is 34. 34 plus 6 is 40, right? 44 is not less than 40. 44 is actually greater than 40. So once again, guys, if you pick a value that's greater than 3, right, then it's going to be just like this. It's going to prove this inequality to be false, okay? So this side is not true, right? This side, or picking a value that's greater than 3, will cause the inequality to not be true, while following our answer will cause it to be true, picking a value that is less than 3. So once again, guys, I just want to show you both sides of how you can check, okay? So thank y'all so much, guys. Have a great weekend.